Good morning, everyone. Welcome to Chemistry with Professor John. All right. We are looking at stereochemistry. This is a quick review and some of the homework uh, exercises. Okay. All right. Let's get to it. Now, the first thing we need to do is to be able to recognize a chiral carbon. All right. Now, a carbon is chiral. Okay, very simple. If it's bonded to four different atoms or branches. Okay, and this is true like 99% of the time. It's also true for other atoms as well, like nitrogens. Okay, for example. Now, if the atoms are the same, then you go to the next one. You compare. Okay, so for example, this one is chiral. It's connected to an oxygen. It connects to a hydrogen. So that's different. It's connected to a carbon. Okay, you can think either way. Okay, the other one is also a carbon, but you go on to the next one. It's another carbon on this side, on the right side. It's just a methyl. There's no other carbon. Or you can just look at it in the substituents way or the branches way. It's a methyl and that's an ethyl. So that's different. Okay, and you got a hydroxy, you got a hydrogen. So four different atoms or branches. That carbon is chiral. We put a star on it. Okay. And if you remember, if a molecule has one chiral carbon, the molecule is chiral. Overall molecule is chiral. Okay. Here's another example. Yep. Chiral. All right. So you can see right here, four different things bonded to it. As we discussed in the lecture, if you have a molecules, okay, and if you compare with the mirror image molecules, and they're different, so therefore they are enantiomers to each other. In this case, there's a different nomenclature. We put plus versus minus, okay, but you can also assign R versus S, okay. Okay, here's a couple practice for us. Identify chiral carbons and label them with the star for each of the following molecules or compounds. All right. Now, every time you see a CH3, that's not chiral because that's three identical hydrogens. CH2, two identical, that's not chiral. CH2, not chiral. But when you get to that one, it is chiral, okay? Because you look at that one, nitrogens, and there must be a hidden hydrogens there, okay? That's four different things, so that's chiral. This one, that's chiral right there, okay? All right, this one is interesting. That should be chiral. That should be chiral. And that should be chiral, right? So we got at least three there. Okay, so let me know if you see another one there. That's dextromethorphan. Okay, that's cough suppression. That's pretty cool molecules. Alanine, that's amino acid. Conine, that's poison hemlock. Menthol, very popular, right? Should be one right there, should be one right there, and should be one right there. So we got three chiral carbons. Okay, here's a summary of what we've been talking about. If a compound has one chiral carbon, it is chiral overall. Okay? It is possible for a chiral compound has no chiral carbon at all. Okay, so that's interesting. And we're going to look at that. We did look at that, right? In the case of two double bonds in a row. This one. Okay, this one has no chiral carbon, but this one, chiral compound, with no chiral carbon. Okay. Optical rotations, you stick a sample of chiral compound in a little instrument like this, and then you shine the light, plant polarized light, and you get the rotations. Okay, and that's how you tell the compound rotate the light positive or negative, to the left or to the right. More example. Okay. Assigning. Okay, so how do we assign R versus S? Okay, and we organize them by atomic numbers. So let's say this carbon is chiral. It's bonded to 4 different atoms. So sulfur has the atomic number of what? 16. So that's 1. And then carbon, and another carbon, and hydrogen should be number 4. Now, this carbon is bonded to 2 oxygens. That's why it's number 2. And methyl is number 3 because it's just methyl by itself, carbon. Okay, so when you do the rotations, 1, 2, and 3, right? That's counterclockwise is S. Okay. Now this one is oxygen is higher 1, carbon with 2 oxygen 2, 3, 4. Notice hydrogen is towards the viewer, so 1, 2 is actually the other way. It's S, right? Okay, so you guys can practice, the rest of them, and you can see the answers right there. That's S. Counterclockwise is S. Okay, we got S right here. This one look like R. 1, 2, 3, hydrogen's 4. It look like R, but it's actually S because hydrogen's is towards the viewer. Okay. Now this one is 1, 2, and 3. Hydrogen's away from us. So it's perfect. 1, 2, 3. It is what it is, R. Okay, we got a meso right here, has a plan of symmetry. So this molecule is meso, meaning it has 2 chiral carbon, but they mirror image to each other, so they cancel out. This one, no, because one oxygen towards the viewer and 1 oxygen's away. So this is chiral. Okay, and then you can assign that too. So that's hydrogen's away. So that's 1, 2, 3. That look like R. Okay, the other one also R. Okay, 1, 2, 3 look like S, but it's actually R as well. This one hydrogen's away from us, so that's good. 1, 2, and 3. So that's counterclockwise. 1, 2, 3. That's S. And then this carbon right here has a hydrogen. Remember, it's towards the viewer. So we got to be careful. Towards the viewer. All right, so that's 1, 2. Okay, this one right here. 1, 2, 3, hydrogen 4. So 1, 2, 3 look like S, but it's actually R. So if you got 1 S and 1 R, cancel. So overall is achiral compound with 2 chiral carbon. Okay. Here's a summary of stereoisomers. Now, if you got 2R and 3R and 2S and 3S, they're enantiomers. You got 2S, 3S, 2R, 3R, also enantiomers. Okay, you got RS, SR, enantiomer, so it's opposite, right? Diastereomer, you got all kinds of combinations. All right. Here's a review of racemic mixture, 50% of each. No net optical rotation because RS cancel out. This is a mixture though. Each compound is chiral. Percent EE, we talk about that. If you got 90% R, 10% S, so the difference is 80% extra R, right? Because 10% cancel out. More example of enantiomers. We got the S, okay. Remember, hydrogen so is towards the viewer. Okay, so it looked like clockwise, but it's actually R. Okay, and the other one looked like I'm sorry, this one it looked like counterclockwise, but it's actually clockwise. And this one is it looked like clockwise, but it's actually counterclockwise. So it's opposite. So you guys can go through and check it out. Okay, now nitrogen is core is supposed to be chiral, but because of the lone pair, it flipped back and forth. So it's actually a racemic. That's why we don't see chirality. Racemic. So 50% of one nitrogen and compound, 50% of the other one to get flipped. Okay, and it's rapid conversions between R and S. Make it overall cancel out, so not chiral. Okay, and we can treat the lone pair just like hydrogen. It's the lowest one. Yep. So in this case, it's R. If it's locked like that. Okay. Yep. That's pretty cool. With an atom that has only 3 bonds and a lone pair, that is chiral. If everything locked up like that. Okay. That's a good exceptions. Now that sulfur is really cool too. It's got a lone pair with 3 branches. So it's chiral as well. Okay, but these are rare, right? So treat the lone pair just like hydrogens. Prochiral, like it's not chiral, but it's ready to be chiral. Butanone is not chiral, but if you do the hydrogenations, you adding hydrogen basically, and you put a hydrogen in carbon, you put a hydrogen on the oxygen. You know, I should say hydrogen in the form of hydride. Okay, and you get the now you got that carbon chiral. Okay, it's a reducing agent. And then when you do that, you can put the hydrogens on the top, or you can put the hydrogen on the bottom. That gives you two different enantiomers. Okay. For the sp3, okay, for the sp3, now this carbon is not chiral, okay, but if you change one hydrogen to something different, then it becomes chiral. Okay, so we can call that prochiral. So those 2 hydrogens, it's one is pro R and one is pro S, meaning if we change it, it's gonna be R. If we change the other one, it's gonna be S. Okay. In this case, we change it to deuterium, which is slightly heavier hydrogens. It's a hydrogen with a mass of 2. Okay. Yeah, so it's pretty cool. And then here's your homework. Decide this molecule is chiral or not. It has 2 chiral carbon, and I believe they don't cancel out. So if you do carefully, I mean, there's a hydrogen in the back. So that's 1, 2, 3. I'm looking at and I see that's R. The other one look like S, it's actually R as well. So this is chiral. It's R, R. Yep. This one is really cool. It's got a plane of symmetry right there. So obviously it's achiral, right? If you turn this just about 90 degrees, it's gonna be the same. So these two are the same. Right? Oh, I'm sorry, it's not the same. It's they mirror image each other and they're not stackable. So they mirror image each other and they're not stackable. They're enantiomers. Sorry about that. Enantiomers. Yeah, this one is cis. This one is trans. The best guess would be diastereomers, right? All right, so on and so forth. You guys can give it a try and then check out the answer key. Cool, everyone. That's a good summary of steel chemistry. Okay. Well, thank you for watching, everyone. Have a good day.